Hello children, today in this video we will learn how to perform experiment number 3. In the previous video we learned experiment number 2. The aim of the experiment was to carry out few chemical reactions and then identify those chemical reactions as physical or chemical change. Okay, so let us start. The first is aim. Okay, now the aim of the experiment is to prepare a true solution of common salt, sugar and alum in water. So we already know what is solution. We have learned this in chapter number 2. Is matter around us pure? Now solution is a homogeneous mixture made up of two or more substances. So over here we will prepare a solution, a true solution of sugar, salt and alum in water. Then we will prepare a suspension of soil, chalk powder and fine sand in water. Now what is suspension? We know in suspension it is a heterogeneous mixture, right? And in suspension the small particles of the solid, they remain suspended in the liquid without dissolving in it. So you can find the solute particles spread throughout the liquid, or you can say they remain suspended in the liquid. And then the third one is to prepare a colloidal solution of starch in water and egg albumin in water. We know colloid. What is colloid? Colloid is a kind of solution in which the size of the solute particle is intermediate between those of true solution and those of suspension. It means the size of the solute particle, it is bigger than solution but smaller than suspension. Okay, so first we will prepare true solution, suspension and colloid, and then we will distinguish each one of them on the basis of transparency, whether they are transparent or not, filtration criterion and stability. Okay, now before starting with the procedure we should know what all materials and chemicals are required for this experiment. So for this we need beaker, okay, few beakers are required, an iron stand, a glass rod. Okay, now it's a rod which is made up of glass and it is used for stirring, for mixing the content together. Then we need Bunsen burner, test tube stand, funnel. Okay, for filtration we need funnel, tripod stand, filter paper, a small torch, china dish, common salt, sugar crystals, alum powder, chalk powder, fine sand, one egg, raw egg, some fine soil from the garden and distilled water. Now distilled water is a type of purified water. Okay, this purified water does not contain any impurities or contaminants. Fine. So now we will start with the procedure. So the first step what we will do is to prepare true solution of sugar, salt and alum. Okay, so the first is to prepare a true solution of common salt. Now for this what we will do, we will take a clean and dry beaker and we will pour 100 ml of distilled water in that beaker and we will add a pinch of common salt in it, and then with the help of glass rod we will mix it. Now we know salt will dissolve in water. Okay, so once it dissolves completely we will get our true solution of salt. Okay, now we will see how to prepare true solution of sugar. Now for this, again we will take a clean and dry beaker and we will pour 100 ml of distilled water and we'll add few crystals of sugar. With the help of glass rod, we will stir all the contents. So we know sugar dissolves in water. So as sugar will dissolve in water, we will get our true solution of sugar. Then true solution of alum. Now for this we need a clean and dry beaker, and to that beaker we will add 100 ml of distilled water and a pinch of alum powder. Then we'll take a glass rod and we will stir all the contents in it. Now the alum will dissolve in water and it will form a true solution of alum. Okay, so this was preparation of true solution. Now we will see how to prepare suspension. Okay, so first is suspension of sand in water. Now for this we will take a beaker and to that we will add 100 ml of distilled water and we will add 10 gram of fine sand in it. Now we know that sand will not dissolve in water, so with the help of glass rod we will just give it a stir. After stirring it, keep this sand in water mixture undisturbed for some time and then we will record our observation. Now after preparation of sand in water, we will see how to prepare chalk powder in water. Now for this we will take 100 ml of distilled water in a beaker and to that we will add 10 gram of chalk powder in it. Then what we will do, with the help of glass rod we will stir it well. Now we know that chalk powder will not dissolve in water. Okay, so after stirring, keep it undisturbed for some time and then we will record observation. Now we will see how to prepare suspension of soil in water. Now for this we will take a beaker and in that beaker we will pour 100 ml of distilled water and we will add 10 gram of soil which is taken from the garden and we will mix the mixed contents with the help of glass rod and we will allow it to stand or we will keep it undisturbed for some time and then we will record our observation. So this was preparation of suspension. Now we'll come to preparation of colloidal solution. So first one is colloidal solution of starch in water. Now for this we will take a china dish and in that we will add 1 gram of starch and 10 ml of distilled water and we will stir the mixture. Then we will take 90 ml of hot boiling water. Okay, take 90 ml of hot boiling water and pour the contents in the boiling water. We have prepared starch, 1 gram of starch and 10 ml of distilled water. So we have to pour that content in 90 ml of hot boiling water. Okay, give it a stir and then let it stand undisturbed for some time and let it cool and then we will record our observation. Now we will see how to prepare colloidal solution of egg albumin in water. Now for this we will take 10 ml of water in a beaker. Now egg has two parts. One is the yellow part known as egg yolk, and the white part is known as egg albumin. Okay, so we will take 10 ml of water in a beaker, and we'll take very small quantity of the white portion or egg albumin. Okay, and then we will mix the content thoroughly with a glass rod. Now to this 10 ml water and egg albumin, we will add 90 ml of distilled water, and you have to stir continuously. Okay, after that, after adding 90 ml of water, we will add few drops of dilute hydrochloric acid, that is dilute HCl. Okay, so now after doing that, we will get the colloidal solution of egg albumin in water. Okay, and then we will record our observation. Clear? So we have learned how to prepare true solution, colloidal solution, and suspension. Now what we will do, we will record our observation on the basis of transparency, filtration, and stability. So let us look at the observation table. Okay, so first we will look at the size of the particle. Okay, now in true solution, the solute particles are not visible. Okay, the size of solute particle is very small. It is less than 10 raised to minus 9 meter. Now we'll look at the size of particles, size of solute particles in suspension. So in suspension, the size of solute particle is more than 10 raised to minus 6 meter. Okay, we can see the solute particles. Now in colloidal solution, the size is intermediate between true solution and suspension. So it will be between 10 raised to minus 9 to 10 raised to minus 6 meter. Now let us check the nature. We know true solution, it is homogeneous. It means if you take a true solution, okay, if you take sugar solution, you can see that the composition looks same throughout. So it is homogeneous in nature. Now if you take suspension, okay, if you take this chalk powder in water or sand in water, okay, can see that it is heterogeneous. They do not look same throughout. The composition is not same throughout. And colloidal solution. When you look at colloidal solution, okay, starch solution, or if you take soap solution, it will look homogeneous, but it is actually not homogeneous. It is heterogeneous, because if you take some amount of starch solution or soap solution, and if you observe it under microscope, you can see different tiny particles floating. Okay, so it is not homogeneous, it is heterogeneous. Now we look at the visibility. Now in true solution, the size of solute particle is very small. They are extremely small, so they are invisible to naked eye. We cannot see it with our eye. Even the solute particles are not visible under the microscope. They are extremely small. Now in case of colloid, the solute particles are invisible to the naked eye. We cannot see it with our eye, but it can be viewed under high power microscope. And suspension, we can see the solute particles with our naked eye. The next comes stability. Okay, now for this we will take one sample of colloid, suspension, and solution, and we will check for stability. Okay, first is true solution. So let us take a sample of sugar solution, and let us keep this sugar solution undisturbed for some time. So do you think the solute particles will settle down? No, right? So in true solution, the solute particles, they do not settle down and they are stable. In case of colloids, okay, if I take starch solution and if I keep it undisturbed for some time, so the solute particles, they will not settle down and they are stable. But when you centrifuge them, okay, on centrifugation, these particles will definitely settle down. In case suspension, if I keep this chalk powder in water mixture undisturbed for some time, what will happen? The chalk powder will slowly settle at the bottom, okay, and they are unstable. Now we'll come to filtration. So for filtration, we will use filter paper. Okay. So if I take sugar solution and if I pass this sugar solution through filter paper, so what will happen? All the solute particles will easily pass through the filter paper and no residue can be seen on the filter paper. If we come to colloidal, okay, let us take starch solution. And if we pass this solution through filter paper, what will happen? All the solute particles will easily pass through the filter paper and no residue is seen on the filter paper. In case of suspension, if we take chalk powder in water and if I pass this through filter paper, what will happen? All the solute particles, they cannot pass through the filter paper and you can see residue collected on the filter paper. Now we'll come to transparency. Okay, so for transparency, what we will do? We will take a sample of sugar solution, starch solution and chalk powder in water solution. And what we will do? We will paste a white paper on each test tube. And that white paper will have a tick mark. Okay, it will have a tick mark on it. And now what we will do? We will try to look, okay, with the through the contents, we will look at the tick mark. Now sugar solution. Now can I see the tick mark easily through the sugar solution? Yes. If it is, if you can see the tick mark easily, then it is transparent. So in case of true solution, we can see the tick mark easily. So it is transparent. Now colloidal solution, it is not transparent. It is translucent. And in case of suspension, the tick mark is not visible. So it is opaque. Okay. So children, I hope you have understood how to perform practical experiment number 3. Okay. Thank you.